Hello guys, welcome back to my YouTube channel. My name is Vivek and today we will talk about the type of beams. In the last video we talked about the type of supports and their reaction. So before going forward, you can check my last video for the better understanding. And guys, if you like this video, then please support my channel by subscribing. So now let's start. First, we will try to understand what is a beam. Beam is a structural member which is designed to carry the transverse loads acting on it. What does it really tells us? Beam is a structural member which is designed to take the loading perpendicular to its surface. But does it means on the beam only perpendicular load acts? Answer is no. On the beam there can be inclined loading, and due to that inclined loading there will be the two components of the forces, or we can say the load. One will be in the x direction and other will be in the y direction. Component in the y direction is perpendicular to the surface of the beam. So when the transverse load act on the beam, then due to the transverse load, bending moment and shear force is generated inside the beam. That is why we say that beams are designed to resist the transverse loading, or we can say that the beams are designed to resist the moment and the shear force induced in them due to the transverse load. When the load acts on the beam transfers that load to the end points on which it is supported. For example, if the beam is resting on the column or walls, and if we apply the load on it, it will transfer that load to the column, and from the column, load is transferred to the foundation. I hope now you have understood what is a beam. Now suppose this is one beam and some transverse load is acting on it. Let's take the section at XX and cut that beam. When we take a closer look at the cross section, we will see due to the transverse loading, there are three internal forces developed in the beam, which are normal force, shear force, and the bending moment, which ultimately induce internal stresses, strain, and the deflection in the beam. Here we can see this axial force is normal to the cross section and shear force is acting parallel to the cross section. We know the shearing force is algebraic sum of all transverse force acting on either side of the cross section of the beam. Now suppose there is a beam, and when the point load acts on the beam in the downward direction, beam will deflect downward like this. Due to this downward deflection in the beam, we will have the moment like this. We can see that when the beam have deflection like this, top fiber gets shorter, means they are under the compression, and we can see that bottom part is getting stretched. It means that they are under the tension. Due to this tension at the bottom, there are the chances of the crack at the bottom of the beam. This behavior of the beam is called the sagging of the beam. We saw that due to the sagging of the beam, top part of the beam comes under the compression and the bottom part of the beams come under the tension. It means in the top part, normal forces will be compressive, that is represented in the inward direction, and in the bottom part, normal forces will be under tension, that is represented by outward arrows. Due to these normal forces, we can see that couple is generated, and we know due to the couple, moment is generated inside of the beam, and here we can see that it will be in the anti-clockwise direction. This is how moment occurs inside of the beam due to the loading. We already discussed about the sagging bending moment. Sagging bending moment is also called the positive bending moment. In another case, when the beam deflects upwards, beam will have the top part under the tension and the bottom part in the compression. We should remember hogging bending moment is also called as negative bending moment. Now we will see the different type of beams. Beams are classified by manner of their support. First we will discuss about the simply supported beams. Best example of the simply supported beam is beam which is resting on a brick wall. You can see this is a simple beam which is resting on the two wall. It is called the simply supported beam. There are three ways to represent the simply supported beam. First one is beam whose both ends are resting on the roller support. Second one is beam whose both ends are resting on the hinge support. Third one is a beam whose one end is a hinge and other end is the roller support. Now we will see in the construction of the simply supported beams why both ends are not roller support or both hinge support. Before that, first we will discuss little bit about the roller support. You can see that when this guy is trying to push this circular grass stack, we know it will get displaced because of the push from this guy. Same is for the roller support. When we apply the load on the beam in the horizontal direction, roller can't resist the movement of the beam in the horizontal direction. It only restricts the movement of the beam in the downward direction. If you want to know in detail about this, you can click on the link and check my last video. Next one is hinge support. Hinge support has a circular pin inside it, because of which beam can rotate freely at the support. When the load is acting on the beam, hinge resists the movement of the beam in the horizontal and the vertical direction, and so it generates the two reaction component, one in the x direction and other in the y direction. But when the movement acts on the beam, hinge allows the rotation of the beam, hence the reactive moment at the hinge support is always zero. So let's talk about the first case of the simply supported beam in which both ends are supported on the roller. Let's assume that P amount of inclined load is acting on the beam. So there will be the two components of that P force, one in the vertically downward direction and other one in the horizontal direction. Due to the transfer component of the force, reaction will be generated at the support in the vertically upward direction as roller resists the movement of the beam in the downward direction. But at the same time, horizontal component of the force P cos theta is acting on the beam. Before we have seen that roller cannot resist the movement in the horizontal direction. So in this case also, the force will act like the guy pushing the stack, like I showed you before. So in this case, beam will get displaced in the horizontal direction because roller won't be able to restrict the movement, because there is no constraint for movement of the beam in the horizontal direction in the roller. This is the reason we don't prefer this type of a beam and support combination. If we use it in our structure, it will make our structure unstable. Because we know in our structure, load can occur from any direction, not necessarily the vertical direction. It can be horizontal, vertical or inclined. So this situation can be avoided by providing at least one hinge support. So let's talk about the next case of the simply supported beam in which both ends of the beam are hinge supported. Let's assume that this beam resting under the hot weather. Because of it, temperature of the beam will rise. Due to this, beam will try to expand in the horizontal direction. We call this behavior of the beam as thermal expansion of the beam. But in this type of the support, there is a constraint in the horizontal direction from the both sides. Due to this, thermal stresses will be developed in the beam as it will oppose the expansion of the beam in the horizontal direction, and it will force the beam to buckle. So this is how beam will look after the buckling. So due to this inappropriate support condition, unnecessarily beam has to be designed for thermal stresses also. Because we know a beam might fail if temperature exceeds the limit. So this situation can be avoided by providing at least one roller support, as roller allows the linear expansion of the beam because it has no constraint for the horizontal movement of the beam. So from the above two cases, we understood that purpose of the hinge support in the structure is to control the inclined load by restricting horizontal movement of the beam, while roller support helps in releasing the thermal stresses generated inside the beam by allowing slight expansion of the beam in the horizontal direction. So when we combine these two support, we get another case of the beam in which one end of the beam is supported by hinge support and other one is biroller support. This is the best case in terms of the structural point of view, as it controls the inclined load with the help of the hinge support, and it prevents the thermal stresses from occurring inside of the beam due to the roller support. So when there is a load acting on the beam, there will be the three reactions generated at the support of the beam. Two due to the hinge support and one due to the roller support. If you want to know more about how these reactions are generated, please check my previous video. So this was all about the simply supported beam. So now we will see what continuous beam is. As the name suggests, we can understand that it is the type of the beam which is continuous over more than two supports. This is so simple case, as we can see the beam is resting over three different supports. Such beams are called as the continuous beam. In structural notations, we represent this type of the beam like this, in which we can see that beam is continuous over one hinge support and the two roller supports. One thing we should understand here is there can be the number of supports in this type of the beam. If the beam has at least three supports, it will be called as continuous beam. So we can say that in the continuous beam, minimum number of the supports are 3. So the next type of the beam is fixed beam. It is the beam which has its both ends fixed inside the supports, and its movement is restricted in all directions. Suppose this is a beam and we will fix this beam inside the two walls, it will be called as the fixed beam. In reality, this fixed portion is inside the wall, so it is not visible to the eyes. So we will see it in another view. So this is a beam and its one end is fixed inside one wall and other end is fixed inside another wall. Such type of the beams are called as fixed beams. When we see it with another angle, it will look like this. In this image also, you can see the beam which is totally fixed inside the support. Now let's talk about the reaction in the fixed beam. When the load acts on the beam, there will be the total 6 reactions generated at the support, 3 due to each support. Next type of the beam is cantilever beam. In this beam, one end is fixed inside the support and other end is kept free. Such type of the beam arrangements are called as cantilever beams. So this is how the cantilever beam looks like in 3D. We can see one end is completely fixed inside the support and other end is kept free. Now let's see how many reactions are generated in the cantilever beam when the load acts on it. There is one fixed support and other one is free support. We know due to the fixed support there will be the 3 reactions generated at the support, and as other end is free to move in any direction, no reaction will be generated at other end due to the application of the load. So basically in the cantilever beam, total 3 reactions are generated. So this is all about the cantilever beam. Next type of the beam is overhanging beam. It is the beam which has one or both ends extending beyond its number of supports. Such beams are called as overhanging beams. This type of the beam has feature of both simply supported beam as well as the cantilever beam. In this figure, we can see that beam is resting on the 2 supports and its ends are extending beyond its supports. In this portion of the beam extending beyond the left support is called the left overhang, and the portion which is extending beyond the right support is called the right overhang. Based on the number of overhangs, this beam is further divided in 2 parts. First one is the single overhanging beam. It is the beam in which beam is extending on only one side of the support. Second one is double overhanging beam. It is the beam which has its both ends extending beyond the support. Such beams are called as double overhanging beam. Next type of the beam is prop cantilever beam. It is the type of beam which has its one end fixed and other end is simply supported on the roller. When the load acts on the beam, total 4 reactions are generated at the supports. 3 due to the fixed support and 1 due to the roller support. So these are the types of the beams based on the support conditions. Now we will see the classification of the beam based on the geometry. This is a quite easy part. First one is straight beam. This is the beam which we generally use in the construction. Second one is curved beam. Curved beam look like this. Third one is tapered beam. This type of the beam has tapered shape. Now we will talk about the classification of the beams based on the cross section. In this type, beams are classified based on their shape of the cross section. First one is I-beam. Second one is the T-beam. Third one is the C-beam. And fourth one is the rectangular beam. It has the rectangular cross section. And last one is the angle section. So this was the classification of the beams based on the cross section. Next one is classification of the beams on the equilibrium condition. First one is statically determinate beams. It is the beam in which only equilibrium conditions are enough for analysis of the structure. Analysis of the structure means to find unknown reaction forces. Second one is statically indeterminate beams. It is the type of beam in which only equilibrium conditions are not enough for analysis of the structure. So, to find the reaction forces, we need some additional equilibrium condition. In the next video, we will see this topic in details. Also, we will see how to find determinacy of the beams. So guys, this was all about the type of beams. I hope I explained you well. If you have any doubts or suggestion, you can tell me in comments. And if you like this video, then please like and share this video and please subscribe my channel for more educational videos. Thank you.